This is the SafetyLens web application. The dashboard view shown gives an overview of the function safety projects. It serves as the starting point of function safety analysis. Let's load Project A and switch to the Compare view. The Compare view is the main view of SafetyLens. The project panel shows the selected project as a clustered node link visualization. Each node represents an element in the project. By default, nodes are colored by their ASILs and are grouped based on their types. Each edge represents connections between nodes. Hovering on a node highlights it and shows details in the detail view on the left. A common task for analysts is to examine a node's neighbors. To accomplish this, we first hover on the target node, which also highlights its neighbors. We right-click on the node and select Connections from the resultant context menu. The nodes and links are now selected and appended to the nodes and links data tables respectively for analysis. Another task analysts perform is to find orphan nodes, that is, nodes that have no neighbors. To accomplish this, we open the control panel and set the degree slider to 0, filtering out nodes that have neighbors. We select the remaining orphan nodes via a lasso operation. As part of function safety, all hazardous events are assigned a risk called ASIL, that is either A, B, C, D, or QM. An unassigned ASIL is a concern that needs to be addressed. We open the control panel again, and this time hide all node types except hazardous events. We select all nodes with ASIL hyphen and make a note of it. It is important for a function safety requirement to define at least one technical safety requirement. Similarly, a safety goal should define at least one function safety requirement. To verify these, we open the control panel and switch to the Link tab. We select the associated FSR relation that shows all links between a safety goal and a function safety requirement. We see that all safety goals do have at least one function safety requirement. We deselect this and instead select associated TSR. This shows all links between function safety requirements and technical safety requirements. This time, however, not all function safety requirements have a corresponding technical safety requirement. Concerned, we export this view to report to the concerning team. While the previous task was to find connections between node types that have direct paths, SafetyLens also lets users be able to find indirect paths between node types. For example, we can check if a technical safety requirement is defined for a given system behavior. In graph terms, this means tracing a path from point A to point B. Let's illustrate this with an example. We switch to the Trace tab, look up a known system behavior, and set it as source. We pick a technical safety requirement of interest from the visualization and set it as destination using the context menu. SafetyLens finds a path between these two nodes, which can be seen in the visualization as well as the data table below. We now want to compare the end-to-end trace of ASILs right from the system behavior to the technical safety requirement. From the table as well as the node link diagram below, we see that the ASILs are fairly consistent. SafetyLens also shows a breakdown of ASILs into their severity, exposure, and controllability constituents in the form of a heat map. From this, we find that even though ASILs are consistent, there is some discrepancy in their severity, exposure, and controllability values. Until now, we have focused our analysis on exploring a single project. SafetyLens also supports comparative analysis among multiple projects. To illustrate this, let's go back to the dashboard and add 2 more projects. This time, let's first go to the summary view. We see 3 tabular heat maps, each showing the distribution of project elements grouped by their node types, link relations, and ASILs respectively. This view can be used to perform quantitative comparison of key metrics across projects. For example, Project B has the highest number of nodes and links. And there are 15 nodes and 4 links common to all 3 projects. Let's now switch back to the Compare view. We now see 3 panels juxtaposed to one another, each representing one project. A new shared view is visible on the left, with the nodes and links that are common to the loaded projects. The clusters are fluid and can be dragged around. To aid comparisons across projects, let's fix them in similar relative positions. To optimize time and resources, an analyst always tries to reuse node and link definitions from existing projects instead of redefining them. For example, in the shared view, let's hover on the only system behavior. We see that it is common across all projects along with a few connected malfunctioning behaviors. Let's hover on one of these malfunctioning behaviors. We can see that there is no shared edge with any hazardous event, which means not all projects have identified the same hazardous event for this malfunctioning behavior. We see that Project C has 2, Project A has 1, whereas Project B has no link. If required, we can potentially reuse definitions from Project C into both Project A and B. In conclusion, we saw how SafetyLens helps analysts perform exploratory analysis of a single project as well as comparative analysis across multiple projects to ensure functional safety of vehicles. To know more about SafetyLens and functional safety, please read our paper. Thank you.